This practice 10 worksheet for Algebra 1 is on graphing lines. And we're going to look at how slope connects to or can be referred to as the rate of change. The top examples, number 1 and number 2, discuss the two ways that we have talked about finding slope. And one is finding slope from a graph, okay, by making a right triangle and counting the rise and the run, and then making it a reduced fraction. And I always say, like, when you get your slope, the slope here is -1/2, you should look at your graph and make sure that, in fact, there is a negative slope on your graph. And so this is correct. Number 2, we're using the formula y sub 2 minus y sub 1, x sub 2 minus x sub 1, as stated here. Okay. Again, you get it, you subtract, you get a fraction, and you reduce it. And we know that m is equal to -6 for this example too. There are 3 different ways to look at the formula of slope. Rise, how much you rise up and run over. The change, this is the change in y over the change in x. You'll see delta a lot in math, this delta, which looks like a triangle, and it means change. And that change generally means that you subtract. You're going to subtract the y's, and you're going to subtract the x values to get your slope. Now, for example 3, we're going to look at how slope can help us find the rate of change. The table below shows the cost of using a computer at the internet cafe for a given amount of time. Find the rate of change per hour. Okay, so we can pick, we're going to use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The time is our x, the cost is our y, right? So we can pick any 2 points. So I'm going to pick, let's pick 2 and 7, and then I'm going to pick 8 and 28. Okay. So now I have my 2 points. This is x sub 1, y sub 1, x sub 2, y sub 2. So we're going to subtract 28 minus 7, and then 8 minus 2. Which gives us 21 over 6, and I can reduce that, giving me 7 over 2. Now, 7 over 2 is a positive increasing slope. And if I look at my cost, time goes up, and so doesn't the cost, which means it's an increasing slope. I'm going to circle that so you know. And it's good to leave slope as a fraction if you're going to graph it. But in this instance, when we're talking about money, we're going to say it increases by $3.50 because we're talking about money. Okay? Fill in the sentence frame and enter your answers on the answer tab spreadsheet. All right. So this means that the cost of the internet cafe increases, and you want to type in the word increase. It's not a good color to use right there. And I'll probably write it above. So you're going to put in the word increase by $3.50 every 1 hour, because that's how time is given in hours. All right. Another thing you can look at, we want to decide whether this is linear or non-linear data. And I'm going to move this table down here to try and decide. Linear data should have a constant slope, so it should be increasing or decreasing at a constant rate. And if we examine the x and the y's on this table, you'll see that this increases by 2, giving you a constant rate. And this one increases by 7, giving you a constant rate. So because there's a constant increase on each side, then yes, this data is linear. All right, now we're looking at trolley buses. This table shows the number of trolley buses in operation in the US during certain years. Find the rate of change, which can be used with the term slope, of the number of trolley buses per year for each time interval shown. And it's nicely broken down into time intervals here for you. Complete the sentence frames provided and enter your answers on the Answer tab spreadsheet. So from the years 1980 to 1985, we have, again, think of this as x and that's y. We have the 2 ordered coordinates, 1980, 85, and 678, okay? So once again, this is my x sub 1, my y sub 1, my x sub 2, and y sub 2. And you're going to subtract. It's the change in y over the change in x. So you're going to do 678 minus 823 over 1985 minus 1980. Which will give us 145, so negative 145 over 5. And when you reduce that, it becomes negative 29. Now, again, we're talking about negative 29 over 1. It is a decrease, okay? And you want to look at your data, and it does, in fact, decrease from 823 in 1980 to 678 in 1985. So this means that the number of trolley buses decreases, and when you type it in, it should turn green to tell you right, by 29 buses every year. Again, you have to use your labels provided, year and number of buses. Now we're going to check the interval from 1985 to 1990. So again, I'm going to take my ordered pair off the chart, 1985, 678. And I'm already thinking, oh, look, this actually is an increase to go from 678 buses to 833. X sub 1, y sub 1, x sub 2, y sub 2. Back here. So then we're going to do the change in y over the change in x, which is 833 minus 678 over 1990 minus 1985. And when we subtract the top, we're going to get 155 over 5. I actually want to double check that. I'm double checking my math. Oh yeah, that works. You're going to cancel this, make that a 2. So that's a 5. Yeah, that would be 12. 155 over 5. And when you divide that, it is 31. So in this particular interval from 1985 to 1990, the cost, it should say that the number of trolley buses increases 31 buses every year. Okay, then the next interval we're looking at is 1990 to 1995. So 1990, there were 833 buses. And in 1995, there were 888. And if you label your x sub 1, y sub 1, x sub 2, y sub 2, we're looking at the change in y over the change in x. It gives us 888 minus 833 over 1995. These are all 5-year intervals, so the denominator is going to be 5 each time. And 888 minus, this is going to be 55, which is going to give you 11 when you reduce it. So it is going to increase. Yep, that's an increase by 11 buses every year. All right, the last interval, 1995 to 2000, is 1995 had 888, and 2000 had 953. And as you can see, now we have an increase also. So we have, this is x sub 1, y sub 1, x sub 2, y sub 2. We're going to do the change in y over the change in x, which is going to give us 1953 minus 888. And that's going to be 2000 minus 1995. Again, in the denominator, we have a 5, and in the numerator, we have a 65. So when you reduce that, it's going to be 13. This means the cost of the internet cafe, this means the cost of the number of trolleys increases increases by 13 buses every year. All right, stop and discuss. Is this data linear or not? Well, because sometimes it increases and sometimes it decreases. It is not a consistent slope, so it is non-linear because it is not constant. The rate of change is not constant. Okay, so remember, there are 3 ways to find slope. And when we're looking for the rate of change, generally speaking, we will use the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And if things are linear, it has a constant rate of change. And non-linear, the rate of change is not constant. It is not constant. Thank you.